Okay, class thale shuru. Uh, so in today's class we'll learn about a new chapter. The chapter name is shaft. So I'll provide you all the details like the formula, the way out how you can answer the questions and everything. That means the how the formulation works. Now, before going for shaft, we have to know something basic about it. The basic is that in shaft design, we actually ignore. We don't have to go for extra formulas. Now, I know most of you don't know about few of your formulas because you have not studied that chapter. You have not studied that subject itself, so you will not be knowing that. But that's not a big deal. Yeah, I'll be telling you right now. Just it's the is the just remember it's the prerequisites is a prerequisite of shaft. So what does that mean? That means that you have to know about certain formula. So what is that formula? Just I'm giving you the brief of the formula that will make you understand how it works and what is the formula associated with it. Now try to understand. Let us consider this to be our pulley where two belts are concentrated or overlapped over one another one. So one is P1 and the is P2. No, so as you can see, this belt is wrapped at and consider this angle to be theta, for example, theta. And the thing is that and the friction of coefficient between this between this belt, let me change the color of belt, that will be more significant. Okay, okay. So the thing is that we have to know that this is a for that what we can see that there's a friction between there's a friction between this belt and this pulley. So what happens is that over here over in this span of the contact. So this is called the span of the contact is termed as the wrap angle. So what does that what do you mean by wrap angle? Wrap angle is the angle at which this belt is covered. So as you can see, this belt is covered on the pulley at an angle of theta. That means the contact point area of the contact angle between the pulley and the belt is theta from here to here. So what you can do is
practically, isn't it like it is always at an angle of 180 degree?
Yeah, it can be correct. It can be 180 degree, but I'm just showing for an explanation. It is 180 degree, but not in every case it will be 180 degree. There are some problem. There is termed as line contact, point contact. There are a lot of contacts system. So most of the cases we get 180 degree. Most of the cases. So we cannot say 100% time we will get 180 degree. So as well as that, it depends on the system. So that's why I have considered theta. So theta can be 180. Theta can be also 360. Let me tell you, theta can be 360. So at that time the belt will be wrapped completely with the pulley. That happens in few scenarios. So the theta, that means the theta can be anything. Nothing but theta is the contact angle between the pulley and the belt. So let us get to the point. Now, since the pulley transfers or the pulley transfers motion to the belt or in the other way, this belt transfers motion to the pulley, vice versa, anything. So the motion is transferred through the contact angle. That means the contact area. So what you can do, that means there will be a friction coefficient. There will be friction coefficient mu. Fine. So what you can do is that you could write a formulation. You could write a formula. That is, the formula is nothing but P1 by P2 is equals to e to the power minus theta. So e to the power theta, mu theta, not minus, sorry, mu theta, where P1 is the P1 and P2. P1 and P2 are the loads over here, the forces. Mu is the coefficient of friction and theta is the wrap angle. It is termed as wrap angle. Is that
এটা আমরা আগে যে মানে যেটা স্ট্যান্ডার্ড পুলি আমরা করেছি সেরকম নয় এটা
স্ট্যান্ডার্ড পুলি যেটা করেছিলাম সেরকমই, বাট এখান থেকে একটু আলাদা কেন এখন একটু বলছি। এটা অ্যাকচুয়ালি আমাদের পুলি, আমাদের যে বেল্ট ড্রাইভ বলে একটা চ্যাপ্টার আছে, ঠিক আছে, আমরা তোমাদের ডিজাইনে বেল্ট ড্রাইভ বলে একটা চ্যাপ্টার আছে, তো ওখানে এই পার্টটা একটুখানি বলে বেরিয়ে গেছে, ওখানে ডেরিভেশনসটা নেই। ডেরিভেশনসটা অ্যাকচুয়ালি একটা সাবজেক্ট আছে, থিওরি অফ মেশিনস, থিওরি অফ মেশিনসে পড়ানো হয়, যেগুলো তোমাদেরকে পড়ানো হয়নি। সেজন্য আমি ভাবলাম যে তোমাদেরকে একটু বলে দিই জিনিসটাকে। এটা ওই নর্মাল পুলির মতো, পুলির থেকে এসেছে, আমি বলতে পারি এই একদম 100% এটা ডিরাইভ হচ্ছে নর্মাল পুলি সিস্টেম থেকে। বাট এখানে কিছু চেঞ্জেস আছে, কি হতে পারে কি না হতে পারে, এই সবকটাকে মেনটেন করে করা হয়েছে। বুঝতে পেরেছো কি বুঝতে পারোনি? হ্যাঁ, মানে এটা বেল ড্রাইভের ফর্মুলার থেকে বের করা হয়েছে, ডিরেক্ট পুলির থেকে বের করা হয়, বেল ড্রাইভ থেকে বের করা হয়েছে। বেল ড্রাইভের ক্যালকুলেশন করা হয়েছে, কত টেনশন ইন বেল্ট হয়, কত কিছু হয়, তার থেকে এই জিনিসটা বের করা হয়েছে। এখন
পুলি কি আমরা যে স্ট্যান্ডার্ড ফর্মুলা লাগাতাম মানে টেনশন লাগিয়ে মানে একটা ওয়েটের রেসপেক্ট আরেকটা ওয়েট বার করা, এইগুলো এখানে মানে অ্যাপ্লিকেবল হবে না, তাই তো? এই ফর্মুলা
না একই রকম হবে না, বাট আমি তোমাদেরকে বলতে পারি যে ওটা কিন্তু বেসিক, দ্যাট ওয়াজ দ্য বেসিক। এখান থেকে এটা কিন্তু ডিরাইভ হয়েছে, এটা না যে ওটা ইররিলেভেন্ট কিছু না, ডিরাইভ করেছে। বুঝতে পেরেছো? ওই যে আমরা টেনশন লাগিয়ে বের করতাম বেল্ট টেনশন কত, সেম জিনিসই তো এখানের মধ্যে ইলাস্টিসিটির কনসিডারেশন হয়, প্লাস এখানে কনসিডারেশন হয় যে কত অ্যাঙ্গেলে বেল্টটা পুলির সঙ্গে আছে, ওগুলো ওখানে আমরা কনসিডারেশন করতাম সিম্পল পুলি প্রবলেমে, বাট এইখানের মধ্যে আমরা সেইগুলো করে থাকি। জাস্ট এটাই চেঞ্জেস বলতে, এটাই। ঠিক আছে, ওকে ফাইন। নেক্সট হলো যে আমাদের নেক্সট ইজ দ্যাট হাউ টু আন্ডারস্ট্যান্ড দ্য প্রবলেম, বিকজ উইল বি গেটিং দিস প্রবলেম, উইল বি আন্ডারস্ট্যান্ডিং দিস প্রবলেম about how it works and what are the things. Now in today's question, because it's a important question, this comes near about this question is itself a 15 marks question, 15 to 17 marks question. So you have to pay attention, you have to because you have to draw diagrams, you have to be more confident while doing this, because this is not that it's a rocket science, you cannot do. For that you have to learn lot of formulas. No, this is the only formula you have to remember. I'm telling you, this is the only formula you have to remember. That means this one. The other thing is that the other formulas what we'll be using, it doesn't require such things. Let me tell you, it doesn't require such things. It can be done simply it can be done. So the thing is that now you may ask, so what is the main factor of that? The factor is the how to use the formula and where to use the formula. There are certain things which you have to keep in mind while designing a shaft. Now let me go to a formula where so let me show you, just give me a sec. Let me bring the page, the question, because I need to show you the form. The question will be is a bit lengthy, that's why I have to, it's better to show you the question. Just give me a sec. Just give me a sec. Because my students, some of the students are giving exam on the same question, so I can show you the question, because a similar type of questions will be there, so you don't have to worry about it. So can you okay, it's visible right now. So as you can see, there is a question over here. Can you see the question? Is it clear to you? So it is written that just try to understand. There are two types of question basically. One is weightless pulley, another is pulley with weight. Okay. So as I was discussing about what would be the question, just pay attention. Sorry for the interruption. It got interrupted due to this this issue. So let you can see that there is a question given. Just pay attention over here. So the question is that the layout of a transmission shaft carrying two pulleys. So many of the things. Many of the things are written, so you have to let me summarize this thing. This is a transmission shaft. A and D is the bearings. B and C is the they both are B, C both are pulleys. Now B is the pulley which is having a vertical load. That is vertical. That is a vertical load. That means a belt is wrapped wrapped vertically, as you can see P1 and P2. Similarly, for the pulley C, another belt is wrapped which is exerting a force P3 and P4 but in horizontal direction. So this two shafts are connected or attached to a shaft. Two pulleys are attached to a shaft which is being supported by two bearings A and D on the either two ends. Now what happens is that as you can see that,
B meter force the vertical line or C
yes,
the
yes, yes.
horizontal.
B is vertical, as you can see. V is vertical and C the smaller pulley, and it is over here. Fine. So what happens is that as you can see there is a there what happens where the pulley the force is applied, so the force is applied by the tension on the belt, from the tension on the belt to pulley. So you have to consider, so what will be the data given? Minimum data. Those are the minimum data. The minimum data will be given the force on the, as you can see, the maximum tension on the in the belt of pulley B is 2.5 kilonewton. So that means now you may say, sir, why it is written that it's a maximum tension? So why will you consider this P1 to be a 2.5? This is considered. So you can also consider P2 to be 7. Now we consider P1 to be the maximum tension in the belt. So we consider it. It's not a thing that it's 100% foolproof, but the thing is that we consider it. That's why since it's not a foolproof, we get some certain difficulties or deformities in in shafts, because we are having some problem. We are lagging somewhere while designing these things, because we cannot design 100% safe. So what happens is that this belt is wrapped at an angle of 180 degree. 180 degree. So how it is, how as I think Balaram has told earlier. So the same as I have shown you, 180 degree. How you can get 180, entirely 180. Fine. It is 180 degree wrapped. Coefficient of friction is 0.24. That is, the friction between the belt and the pulley is 0.24. And the shaft is made up of, that is this one. The shaft is made up of plain carbon steel. That is given, the yield stress is given at 400 Newton per millimeter square, and the factor of safety is 3. That means the factor of safety, applied factor of safety, will be 3. So this will be the today's question, as well as for the coming week also, because this question requires time to understand, because it's not a because you have to draw something, you have to draw, you have to draw as well as you have to answer it. So the thing is that for that purpose only you have to wait. So don't worry, let us start. Okay. 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 Is it visible to you people? Is the dashboard visible to you people? I mean, the whiteboard. Is it visible?
Yes, sir.
Okay. So what will be given actually? The given part will be like just my phone got locked, so that's why it. Okay, so this the given part will be power. Number one, the given will be power. Power. Next, it will be given force. Force will be provided. Third will be given wrap angle. And yield stress. Yield stress. Yield stress. FOS. And since we know this is a weightless pulley, we don't have to do anything. Now the power, I don't know how much power is given. At least let me see. Just give me a minute. Let me see how much the power is given. The power is given. Power. Okay, so ignore the power. We don't need actually power right now. So, okay, fine. Okay, so what we can do is that if the power is given also, so let me tell you, this is for the question which will be having much more critical. The power may be given 7.5 watt. So this will be useless for you. The force will be given. Let us given 2.5 kilonewton. Fine, and the wrap angle to be 180. Yield stress, let it be 380 Newton per millimeter square. Factor of safety is 3. Okay. So the thing is that from where we can from there we can get our values. Like what we can do is the first step. The first step is just get me back to the first step is to find out the allowed stress, the allowed force on the pulley. How could it happen now? So for that we have some formulas. Now let me get back to the point. So we know that we have to understand which is driven pulley and which is driver pulley. So there are two types of pulley. One is driver and another one is driven. So what happens is that the power is transmitted from this pulley to this pulley, but that is from pulley B to C. But the thing is that this is transferred by a shaft. But the thing is that the shaft should have a diameter, should have that much of diameter which it could transfer the force or the load to power or torque to this one. So how we can do that? What is the way out to do that? There are a lot of way out to do that. So for that, first we'll find the as usual we know we'll be finding for first step is allowable stress. Allowable stress. So how you can find allowable stress? Allowable stress you can find tau is equals to, tau is the shear load. We know that we have done in the earlier form, that is 0.5 SYT by factor of safety. So we have to find out the allowable stress. How you can find the allowable stress? So finding the allowable stress, we need to find out what is the formula. So what is the formula? 0.5 into the allowable stress is given over here is 380. So what you can do, let me delete it, so that would be much more better. So you can see this is 0.5 into 380 by factor of safety is 3, as we have considered. So this will give us some result. So as we know, factor of safety is 3, and the allowable stress is 0.5 into 380. So let us find out. Let me get to the back. 0.5 into 380 divided by 3 is equals to 63.3. Sorry, just a sec. 60 is equals to 63.33 Newton per millimeter square. This will be my allowable stress. So I will record this thing at the end. But the thing is that since you have to find out the allowable range, because it will give you an idea how it works. So after that, what we'll do, we'll go to find out, we'll be following to another step, that is to find out the tension on the belt. How you can find? As I have told you the earlier formula, the formula is P1 by P2 is equals to e to the power mu theta. Now try to understand. We know that P1 is equals to 2.5 is equals to 2.5, and P2 will find out, and mu is nothing but is equals to 0.24, and theta is nothing but your it's given 180. Now the theta will be have to be provided in radian, in rad, rad. So the thing is that how it will appear. Let us see. বুঝলাম না কি বললে? হ্যাঁ, এটা এই জায়গায় ঠিক আছে। দ্য অ্যালাউয়েবল ফোর্স অর দ্য ম্যাক্সিমাম, আমি তোমাদেরকে একটু তবু কোথা থেকে পেয়েছি, আমি একটা বলেছিলাম ম্যাক্সিমাম দ্বারা, একটা মিনিট আমি তোমাদেরকে দেখিয়ে দিই, তাহলে তোমরা ভালো করে বুঝতে পারো। ইউ পিপল ক্যান আন্ডারস্ট্যান্ড ফ্রম হোয়ার আই হ্যাভ রিটেন দ্য সেম। সো লেট মি রিজিউম মাই let me show you from where I got this one, that it need to be 2.5. See, the maximum tension on the belt is 2.5 kilonewton. Is it clear? So from there only I have got that it need to be 2.5 kilonewton. Okay,
maximum allowable stress যেটা আমি ক্যালকুলেট করলাম ওটা কোন লাগাই তো।
হ্যাঁ, এটা এখান থেকে বের করছি, আমি ধরেছি 380, আর এটা এখানে আছে 400, তো এটা এত কোনো প্রবলেম হবে না। সো এটা ম্যাটেরিয়াল টু ম্যাটেরিয়াল ডিপেন্ড করে। ক্লিয়ার? ওকে, ফাইন। Share screen. Share now. So as you can see now, for here we can Kirandeep এখন join করেছে। As you can see, so the thing is that 180, so 180 means that pi radian. So how you can change to 180 to pi radian? Can anyone tell me how can you do that? Anyone? Mu 0.24, and how much you can change theta to radian? How to change theta to radian? Can anyone tell me how to change theta to radian?
So 180 by 2 pi.
180 by 2 pi. 180 by 2 pi.
What is pi?
180 by pi.
180 হচ্ছে পাই রেডিয়ান, 1 ডিগ্রি হচ্ছে পাই রেডিয়ান বাই 180, সেটা তাহলে কত হবে? পাই বাই 180 ইন্টু থিটা।
180 দাঁড়া, এটা আরেকবার বলো, আমি একে বুঝতে, আমি মানে আওয়াজটা কেটে কেটে আসছে। ওয়ান কত হওয়া উচিত বুঝাও।
180 হচ্ছে পাই রেডিয়ান, 1
এক্স্যাক্টলি।
ডিগ্রি হচ্ছে পাই বাই 180, থিটা ডিগ্রি হচ্ছে পাই বাই 180 ইন্টু থিটা রেডিয়ান।
5/180 থিটা।
পাই বাই 180, পাই বাই পাই বাই
ইন্টু থিটা।
180 না পাই বাই থিটা?
স্যার পাই/180 ইনটু থিটা।
হ্যাঁ, কিন্তু থিটা তো আমি রাখবো না, আমি থিটার জায়গাতে আমি এই
তাহলে পাই হয়ে গেল।
পাই হবে, অনলি পাই।
পাই
ইয়েস, পারফেক্ট। আমার এটাই জানতে চাইছিলাম, পাই। আমি এই জন্য তো বলছি যে আমি এই জন্যই তোমাদেরকে বলছি যে উই হ্যাভ টু কনসিডার, উই হ্যাভ টু টার্ন 182 রেডিয়ান in radian form. That would be pi radian. Now what you need to do, you have to find out, get your calculator and find p2 equals to how much. Just give me how much p2 is equals to how much. How much is how much will be p2? How much will be p2? p2 কত? How much?
1.1762 1.176
1 পয়েন্ট, দাঁড়াও আমি লিখি, 1.17।
6
ও এটা এত এত ইয়ে লাগবে না। সো you can just approximate to 1.2. So what we find, what we got is that we know we got p2 is equals to 1.1, 1.2. Fine. I am not going for any other value. So the thing is that we are getting. Now what we can do is, after that we have to follow some instructions. What are the instructions? Now we know what is p1. Let me go back to this one again. Again let me resume my this one. Sure, now. Okay. As we know that we have got the about we got what is p1, we have got what is p2, right? We are aware of p1 and p2, right? Yes or no?
হ্যাঁ, p1 p2 জানি।
But the thing is that we don't have any clue for p3 and p4. The most important thing is that we have to get these things also, p3 and p4, because they will make the maximum change for p1, p2 and p3, p4. So that means we are aware of 50% awareness. We don't know again after for the next 50%. So what we can do, let's come to the back to the question, what is the way? So there is a small consideration, a small thing what you need to understand. Let me show you the assumption. Now as you can know that B is a pulley by which power is supplied. How you can know that? Just read the question. Power is supplied to the shaft by the means of pulley B, which is then transmitted to C carrying a horizontal belt. Can you see the statement? Can you see the statement? This statement itself describes a lot about how it works. So you have to know, you have to understand that it is telling something very important. So how you can do that? This will give the you the way out how you can get the value of this certain how much is the value and what else not, you can find out from here, p3 and p4. So let us get back. Share, start now. So as we know from the previous formula, as you can see that over here, as you can see over here, that is nothing but P1 by P2. So we'll be doing for same for the P3. So let us do that. No, let us go back to this one. P3 by P4 is equals to e to the power mu theta. Again we know e to the power 0.24. Theta is nothing but pi. Now can you tell me can anyone tell me the value, how much it will be? কত হবে সেটা একটু বলতে পারবে? How much?
2.125.
2.125. Hello. Acha. So what we can do is that from there we have to get some get some data. So let me go get back to the work, to the bench, so where we can get this entire, just give me a sec. Okay, so what we can do is that it's 2.1. So let us consider 2.1. So what is happening is that we know that we can write P3 is equals to 2.1 times of P4. That would give me a equation number 1. Fine. Similarly, as we have read on that one, that this 2, is my whiteboard visible to you people? Is it visible? So we know that this is we could see that there is a P1, P3 and P4 are interrelated to each other. Now we know that this is here the motion is transferred from B to C, as we have as it has been described in the question. Let me go back to the this one. So as it has been described, so this B to C. So for that we could assume. And let me tell you, it's not 100% perfect. We assume that the moment over here, a moment termed as mt, is same over here over there. That means moment at B is same as moment, sorry, not moment, I'm very wrong. The torque at B, B is equals to torque at C. The moment torque at B is exactly same as at C. That means pulley, the torque at pulley B is equals to the torque of at pulley B. It's assumed, it's not the practical thing. Let me tell you again, it's not the practical thing. It's not 100% same, but we assume over here. So what I can do is that since I know that the torque on the pulley B, let us write in this manner. Just let us see on this manner. Pulley B. What happens is that in pulley B, the torque mt is equals to P1 minus P2 mt is equals to P1 minus P2 by into R1. Here R1 is, let me tell you, in R1 the R1 is nothing but your as I can remember, R1 is 250. R1 is equals to 250. Okay, now you can go to the question and you can see. I'll be sharing the question with you people. Now what is P1? P1 is 2.5 minus 1.7. Can anyone help me with the value? Can anyone help me with the value? কেউ আমাকে আনসারটা বের করে দিতে পারবে? What would be the empty value for empty?
স্যার 200
200 এসেছে, এত কম?
স্যার দেখুন 0.8 into 250 মানে 8 into 25 25 200
250 into 2.5 minus 1.
হ্যাঁ স্যার 200
আসছে। আচ্ছা ঠিক আছে, আসুক, কোনো অসুবিধা নেই। 200, oh, correct. Kilonewton, because it's in kilonewton. Correct, you are all are correct. Kilonewton. Now if I consider in newton, it will be much more. Very good. Kilonewton millimeter. Perfect.
স্যার
Now
বলছি এটা কিসের ফর্মুলা ছিল স্যার, P1 minus P2 into R1?
P1 কোনটা?
এই যে ফর্মুলা লাগালেন পুলি বি এর জন্য।
হ্যাঁ, এটা কিসের ফর্মুলা কেউ বলতে পারবে? এই ফর্মুলাটা খুব জেনুইন ফর্মুলা। আমরা টর্ক বলতে কি বুঝি? TORQE, টর্ক ইকুয়ালস টু কি জানি? টর্ক ইজ নাথিং বাট ফোর্স
ইনটু পারপেন্ডিকুলার ডিসটেন্স।
পারপেন্ডিকুলার ডিসটেন্স। পারপেন্ডিকুলার ডিসটেন্স হচ্ছে আর, ফাইন। আর এটা হচ্ছে ফোর্সটা ধরলাম P1 মাইনাস P2। এখন জিজ্ঞেস করবো কয়েকজন, স্যার
আচ্ছা,
কেন
net force,
হ্যাঁ নেট ফোর্স, আমরা নেট ফোর্সটাকে ধরছি। উই আর কনসিডারিং দ্য নেট ফোর্স ফর হুইচ ইট ইজ রোটেটিং। ইজ দ্যাট ক্লিয়ার? Okay, that's what I did. Now, as we know, as we have assumed that the torque in MB is at pulley B is nothing but is equals to the torque at it is same as the torque in pulley C. So I can write MTC. So I can write, just give me a sec. I could write that MTB and is equals to MTC. Is that clear? Clear? So what I can do is that from here I can write one more equation. What can be the equation? Just try to let us see the equation. So this will be no, don't worry, it will be not a rocket science equation that where we have to think twice for it. This is very easy equation. So what I can write, MTC is equals to P3 minus P4 into R2, where R2 is 125 and we don't know what is P3 and P4. Let it be over here, is equals to 200. Now find out what is P3 and what is P4. বের করতে পারবে? Is that clear?
Yes, sorry. P3 ke P4 terms লিখে P4 বার করে P3 বার।
Now, yes, just try to understand. Let me give you one more hint. It's one equation and another equation you have over here. So what you can do? You can find out P3 and P4 easily. Is that clear? So I need the value for P3. I need the value for P3 and P4. I need a value for P3 and P4. I need the value for P3 and P4. Just get the value for P3 and P4 as soon as possible. Just do it very fast.
তো P4 এর 1 পয়েন্ট P4 হচ্ছে 1.454 আর P3 হচ্ছে
হ্যাঁ আমি একটু লিখি দাও, তুমি বলতে থাকবে লিখে। P4 টা কত এসেছে? 1.454। আচ্ছা, P3
হচ্ছে 3.05।
3.05। সবকটা, everything is in kilonewton, so don't worry. So what we got is that this is 1.45 kilonewton and this is now what does that means? That you may ask, sir, after that what will happen? After that, here is the game of bending. We have to find out the value under terms of bending. So because we are doing we will be working out on this one because it's a it happens because only for the load applied the shaft is considered to be having maximum bending and which makes it much prone to prone to deformation. So how you can do that? Now let us get back to this one. So let me get it. This would be so. Okay, now how many of you can tell This is a logic. This is a so this is only for this will give you an idea how we'll approach. Now, how many of you can tell that while I'll be finding the bending, can you find the bending of horizontal load and vertical load simultaneously? Can you find it? Is it possible?
মানে বুঝলাম না
মানে হরাইজন্টাল লোড আর ভার্টিক্যাল লোডের বেন্ডিং একসঙ্গে বের করা যাবে কি?
না মনে হয়
মোমেন্টটা বলতে চাইছি।
হ্যাঁ, মোমেন্ট, বেন্ডিং মোমেন্ট যেটাকে বলি আমরা বেন্ডিং মোমেন্ট, পসিবল কি?
তো সাইমালটেনিয়াসলি একসঙ্গে কি করে বার করবো? একটা বার করলে তো আরেকটা হিন্ডার হবে, মানে আরেকটা তো এফেক্টেড হয়ে যাবে।
Correct. So what is the can anyone tell me what is the answer for this one? How to solve it? তোমরা বুঝতে পেরেছো ব্যাপারটা? তোমরা আরেকটু পুশ করো নিজেকে। How we can solve it? How we can solve it? Can anyone answer me? There is simple way. সবাই
স্যার কম্পোনেন্ট নিতে হবে না?
কম্পোনেন্টও না নিয়ে আরো সিম্পল। Give me answer. You have 5 minutes to answer. Just be fast. Just get the answer.
স্যার বলছি আমার যখন এই পুলি ভিটা ঘুরছে, মানে ঘুরতাম বলছি, তখন এখানে একটা আমার ফোর্স করে ইন্টারনাল ফোর্স করে হবে শাফটে। তো তখন স্যার আমার শাফটটা ঘুরতে আরম্ভ করবে, এবার শাফটটা যদি ঘোরে, শাফটটা পুলি সিটাকে একটা ফোর্স দেবে, মানে রোটেটারি ফোর্স দেবে। তো সেই ফোর্সটা তো পি আর পি3 আর পি4 এর সঙ্গে ইকুয়াল করে আমরা মানে জিনিসটাকে বার করতে পারবো, ইকুয়েশন বার করতে পারবো।
তোমরা কি তোমাদের কে কি জানি একজন বলেছিল, আওয়াজটা কেটে আসছিল, তোমরা একটু বলতে পারবে কি বলেছিলে?
স্যার বলছিলাম যে, স্যার শুনতে পাচ্ছেন?
হ্যাঁ, এখন বলো, এখন শুনতে পাচ্ছি। হ্যাঁ হ্যাঁ বলো।
যখন আমার পুলি বিটা মানে একটা রোটেট করছে, তখন
হ্যাঁ।
শাফটের উপর একটা রোটেটরি ফোর্স ইয়ে করছে, একটা প্রেজেন্ট মানে শাফটের উপর রোটেটরি ফোর্স এক্সার্ট করছে। তো সেই ফোর্সের জন্য শাফটটা রোটেট করতে আরম্ভ করবে। তো শাফটটা যখন রোটেট করবে, তো একটা সিমিলার ফোর্স পুলি 3 কে, মানে শাফটটা পুলি 3 কে এক্সার্ট করবে। তো সেই ফোর্সটাকে আমি যদি পি3 আর পি4 এর সঙ্গে মানে রিলেট করে একটা ইকুয়েশন দাঁড় করাতে পারি, সেখান থেকে আমি বেন্ডিং মোমেন্ট পেতে পারি না?
আর একটু সোজা করা যায় না? ভেরি সোজা, আরেকটু সোজা। তোমরা হ্যাঁ বলো 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 বলো। This is a discussion. You can make it much more easier, much more easier, much more easier. It can be much more easier. Very easy. Now try to understand. Try to understand. Let me give you the answer in the simpler way. Just take my words. Let me start. Okay. So as you know that tell me one thing. While you do an equation like sigma fx, so do you consider the value for fy? Do you consider the value for fy? Yes or no?
না
Nah, corona. The F you don't consider for the Fy. So that means while you are considering horizontal components, you don't consider the vertical components. So what you can do over here, there is a shortcut. The very shortcut. So the shortcut is a logical shortcut. The thing is that that's make much more easy for everyone to understand. Let me give the shortcut. Okay, fine. So start. So what you can do is, you know that there is a load. Just try to get my point. This point is fixed, A point is fixed, and B point is fixed. Sorry, not B, it's D. D point is fixed. Let us consider the horizontal one. Now we know that there is a horizontal load. How we know that a pulley is at B, which is having a vertically downwards? Am I right or wrong? Am I right or wrong? So that means it will have P1 plus P2. But whereas in C pulley, is there any horizontal, is there any vertical load? Is there any vertical load? Yes or no?
No.
So that means this will be neglected for Fy, or you may say that for horizontal, for vertical. So I'll not write the Fy. This doesn't, it doesn't suits for here. We'll write vertical. Vertical. Now what happens is that since A and B points both are fixed to bearing, that means they will give a reaction, that will be RAB, and another will be RDB. Is that clear? Is that clear?
Yes.
So what we can do is that we know that it is RAB and RDB. So that means from here, can we find the vertical movement? Can we find the vertical moment? Can we find, is it possible? Is it possible or not? So
Yes.
how much will be P1 plus P2? Let us get back to the board. What is P1? Let me write over here. That would be given P1 and P2. P1 is 2.5 kilo Newton. Now how much is P2? I forgot P2 how much? 1.7. 1.7 kilo Newton. Now therefore what we can do is we have to get some basic formulas. Now let us get for the basic formulas. The basic formula is, হ্যালো, কে বলছো? হ্যাঁ বলুন। হ্যাঁ বলুন। কোথা থেকে? হ্যাঁ বলুন। হ্যাঁ। হুম। হুম। তো এখন কি করা যেতে পারে সেটা বলুন। আপনি বলুন না কি করলে ভালো হবে এখন। So what we can do is just give me So what we can do is that from here we can find some value, that is P1 plus P2. What is P1, how much is P1, and how much is P2? So we know that P1 is let us get what, 2.5 plus 1.7. Fine. So this will give us a value like 2.5 plus 1.7. This will give us near about 4.2. That means let me summarize this one. This will be 4.2. 4.2. So here I am having RAB, and here I am having RDB. The distance is here to here it is 200, and here to here it is 800. So what I can do is that I can find out RAB and RDB. How I can find out? Now the simplest way is taking moment at A, which is, let me write the name A
কোন পয়েন্টে নেব মোমেন্টটা,
C D. হ্যাঁ বলো কি বলছিলে?
কোন পয়েন্টে অ্যাবাউট মোমেন্টে নেব?
Moment will take a moment from this point. From this point. So what I can write? Correct. So what, let me show you one equation, that is MA is equals to since it is going clockwise, since this force is nothing but it is going clockwise, that's why I can write minus 4.2 into 200 plus RDB into 1000 is equals to 0, from where I could find RDB is equals to how much. Is it clear? Is it clear or not? It a clear na? From here I can find RDB. Next step, what I can do, since I could see this is this things in this entire system is in equilibrium, I could write one formula. What is the formula? The formula is RAB plus RDB is equals to 4.2. So what happens is that from we know that what is RDB, what is we know that what is we know what is RDB, so I can get from the RAB. Is that clear? So that's it, we can find. Similarly for the horizontal load also. So this will continue in the second half, and we'll go for on shape also. Fine. ওকে, এখন
স্যার কোথা থেকে নেবেন স্যার?
3:30।
ওকে, ঠিক আছে।
হ্যাঁ, এতটুকু অবধি সবাই ক্লিয়ার হয়েছে?
হ্যাঁ।
ওকে।